next, we have our academia versus industry panel. So if our panelists want to head on up, we have Lilly moderating the panel. And on the panel, we have Farshid, Alambeigi, José del Millán, Sentis, and Nichols.
All right, how are you all doing? Hope everyone's day is going fantastic, and so we'll kick things off. Really would like you all to introduce yourself, tell us a little bit about your research, your role on campus, and what you're doing overall.
Well, thank you. Am I on? Hello, hello.
Yeah, okay. You're on.
All right, so I'm 15 years in this university. It's starting to be the longest place I have lived in. I run a laboratory. I'm a professor in aerospace engineering, and I run a laboratory called the Human Centered Robotics Lab, and we do deep research in embodiment and human-centered robotics, obviously. But related to this topic, we spin off companies, and then we encourage students to spin off companies, and we work with people like Nichols to make that happen successfully. So that's my role.
José Millán, I am also a professor here at UT. I am professor in electrical and computer engineering. This is my home or main department. But I am also full faculty in the medical school in neurology. The research that we do is around brain-computer interfaces, and in particular in this context, brain-robot interaction, brain control robots for rehabilitation, and also simply to learn directly in a very direct way how to incorporate the cognitive state of the subject into the robot decision-making, how to teach robots using our brain signals, inferring when we like what they are doing and when we are not satisfied with what they are doing, how to personalize their actions and their policies. That's it.
Good afternoon, everyone. I'm Farshid Alambeigi, assistant prof in mechanical engineering department and part of Texas Robotics. So my background is basically the whole lab is doing surgical robotics, building robots and technologies for different indications, different problems, from orthopedics and neurosurgery to cancer diagnosis through endoscopy, colonoscopy, and of course, the main important thing I recently started treating cancer by developing magnetically steerable catheters. Going back to the main point that Luis mentioned, the whole team of my lab is that we are going to write paper, I tell to my students, but more important than that, we try to translate all of these technologies. So hopefully we are going to talk about it. Thank you.
And I'm Nichols. I'm the Director of Business Development, Licensing, and Collaborative Research for Discovery to Impact here at UT Austin. And it's my honor to be on the stage with these big hitters in robotics here at UT Austin. It's as you guys know, an outstanding department and group of folks, and we're doing some really great things.
I probably should have started out with this, but my name is Lilly. I am the Venture Associate for the Texas Innovation Center. We are in the EER, second floor, and we help commercialize University of Texas at Austin IP. If you're a graduate student and you have some really cool ideas, please feel free to come and talk to us. All right, next question. How can academia and industry contribute to sustained progress in robotics? We can start at the end.
Well, I don't think we have to justify it. I think it's happening and is accelerating. There is a completely new wave that we see now on, I'm not going to call it humanoid robotics, but is really general purpose robots. And the fact that we have seen absolutely every high-tech company now jumping in this space. People are searching for an answer of a problem that is ancient, and the problem is that we have a number of tasks that we perform every day that they take us away from spending time with children, with our friends, in intellectual pursuits, in creative pursuits, and And that problem has existed for a long time. And now, only now, with the deep sort of research that happens in academia, we found models, if you will, and design solutions that they're capable of accomplishing these tasks. That's what we are able to perform in academia. A PhD takes about 5 to 6 years. Don't get scared if you are about to pursue a PhD. It's fun, you go out with your friends, you know. but it's really 5 or 6 years you travel.
You don't need to rent a bed because you sleep in the lab.
But really, I mean, you go from being, you know, from being in college, which maybe you have discovered something, but normally you don't have really a footprint in the world of technology and science, to, you know, waiting and deepening into the research and coming out after 5 or 6 years with what I call it IP. I call it PhD IP, to use kind of less language, or the innovation office, but it's really the ownership of the student, right? The student has discovered something, and guess what? That student is only, by the end of the PhD, is maybe 27 years old, 28 years old. So they go outside and they have created a subfield with great depth, right? What we're not good in academia is, aside from, you know, on a scaling overall, right? I'm going to say both in the money. We have small monies, you know, 2-3 million here, right? That kind of buys a lot, but also on the data sets, right? Or on the architectures, right? We create some models and kind of, you know, increasing the pool and the size and the deployment and the robustness to the grade levels, to the scaling at the client level as well, the use cases, right? All of these we're not good at. And that's where I see the synergies between academia that are very successful today and are happening daily, academia and the industry, in particular here in Austin. Thank you.
Well, I agree, and there are two things that we cannot forget, that universities have a reason to be there. It is one, to educate not just PhD students, but any educated future professional, and we need to pay a lot of attention to give and to this future generation of professionals the tools, the basis to excel in whatever they want to pursue. And the fact is that in today's dynamics, what it is guaranteed is whatever profession you choose to start today, chances are very high that in 5 years from now, you will be doing something different. So it is essential that we train our students not just to replicate whatever we teach them, but to be capable to generalize, to be capable to learn by themselves. And this, I think that we, at least here at UT, we do well. Yeah. So this is one thing. The other thing is that I will give an example in my domain. Now, when it comes to human-robot interaction, we want to use not just speech, not just gestures, but we also want to use biosignals to interact with our intelligent devices, robots in particular. Now, I am not saying that the brain signal should be part of this portfolio, at least not in the immediate future. I am convinced that it will be the case in the long term, but this doesn't mean that we cannot learn from that. What the point I want to make is that industry will innovate, will find solutions to exploit whatever biosignal it is easy to pick up, and pragmatically show that people do. But I think that something that all university can do is to say, okay, let's now prove in a scientific way that in fact this is grounded on the existing knowledge, in particular in neuroscience, in more fundamental portions of science and technology, that whatever the solution you have come up pragmatically, it is a sound solution, because this will give you credibility. So these are the dynamics that at a certain moment I see that will be beneficial for both sides, because we will have, and we are eager to have new problems, and we can help to give sound foundations to whatever business solution someone is capable to put forward.
So I wanted to echo the first answer that Jose said. So I tell my students, so my job, let's say, so you're taking a PhD, you're working on one problem, but the most important thing, you want to have the art of problem solving. So definitely, maybe it happens you go to one industry related to what you did in your PhD, but you may actually go to another job and another job. You don't want to say, oh, I worked on this problem, I'm going to just do that. So, but if you learn through this 4, 5, 6 years, God help you if it's more than that. So if you learn how to formulate your problem and then handle any problem with engineering tools, that's basically what you want. This is at best, at the end of your PhD, you're going to ask yourself, if someone throws me another engineering problem or any other problem, can I formulate that or not? So if you go to industry, then you would be successful. Coming back to the other part, how industry and basically university can help each other, I give you the example of Aptronics. So basically, we are researchers. We are working, I say, on the future, hopefully, because I can say you're sort of an advanced R&D of companies. You can innovate, you can work on problems that maybe right now no industry is working on, but let's say BCI or what basically Luis worked on. So it took some time, God knows how much time, 10 years, 15 years, they were working on their own startup, and then now it's the golden time, and that thing happens that you can translate whatever you did, whatever you wrote on your papers, you were thinking about it, you were innovating by the time, if it's going to be translated to the real, basically, word, is it working or not? So what you see as Aptronics right now many papers, I'm sure Luis had in his head, had thought about it, okay, we want an actuator, it should be like that or that, and that became IP thanks to the Discovery to Impact team. Now it's a product. So the good thing is that industry is motivating that there would be a time, hopefully that time doesn't go to infinity soon, that you can translate whatever we are doing, and that's actually the motivating factor for basically a student. So this is a two-sided, let's say, effect that a startup and industry should push university that, look, there is a time that time's coming with Neuralink, with all the technology, with autonomous driving. One day, all of those had been like a paper, conference paper. Now it's reality. So it's just a matter of time to me.
Yeah, to boil it down, as I sat here and listened, to me, it's industry and academia work best when they both collaborate, realizing what they do best, right? Industry is focused on generating revenue, getting more customers, managing their costs to maximize profit, increase the value of the entity. University, and they're driven month by month, quarter by quarter to hit their metrics and to do better. Universities can take the time to focus on a problem and to do that discovery, figure out what are the different ways we can approach this problem, what is the optimal way to solve this problem. And when you see industry and academia really working together, focusing on what they're both good at, then you get really, really excellent results where inventions come out, the company takes rights to it, makes big things happen.
Yeah, I would like to know, Jose, Farshid, you all said something really interesting. And so do you think that industry partners should have more say in what's being taught at the undergrad level? That way there are those that can be exposed to current industry problems, and then that can maybe lead to research happening earlier on in the process before someone gets to their PhD?
I don't think that we are driven by the problems that eventually industry is inspiring us with. In my particular case, I am trying to convey the logical reasoning process, no matter what it is the problem about. And I want them, the students, to come up with solutions with minimal. For example, now, I have just given a problem to the students saying, look, you know that in this experiment, this was the data that was collected. Infer, which was the question. I am not asking, give me the right design that the experimenter had. I want them to come up with a logical derivation.
For undergrads, I mean, I teach the class. During the class, I motivate them all by industrial examples. It's all, I tell them, I joke with them, it's all about money. Because at the end of the day, you get a degree, you want to get, basically, you have a boss. And you are engineers, you're going to design. And I see all the problems as a design problem. So basically, you are having an optimization problem, you are going to satisfy it. At the end of the day, industry is all about money. So I teach this mechatronics class, so I say, look here, I talk about electronics, you have a bunch of options, but at the end of the day, your boss saying, here is the budget, here is the money that you have, and go and design and pick the parts that you have to do the job, right? Coming back to your point, so for undergrads and basically graduate students are two different things. I highly recommend them for my undergrads or even like the class I teach. Definitely go and try industry, do internship, and see actually what you're learning there. Every person, the personality is different. So if your personality is like, for now, I want to do work and then learn basically more real world, do and try it. Maybe at some points you get bored and then come back to academia. It happened to me. I did internship, I mean, right after, like during my PhD, I realized, okay, that's boring. I don't want to do it. I think I made the wrong decision. Anyways, I had more money by the time, so. But came back, I was happy with the job I was doing. So coming back to your question, I guess for undergrads, it's very important, I guess, to see the real world. See actually what they are learning, what Jose is saying. So fundamentals that you are learning is not just to solve a problem, take a test and get A or whatever. It's that actually these knowledge that you are learning, this math that you're asking why we need to learn this integral or whatever, it's very important because it's not about using that integral. It's about the thought process. It's about learning how to formulate problems. And then when you go to industry and see, actually, I'm not using that integral, but I know how to handle that problem. That's important to me. Then once you have that knowledge, when you want to do PhD and grad studies, now you know, okay, I picked this path because I tried it. No, I know this is me, I want to do it. So you would be more successful.
Understood. Thank you both for your responses. What roles should each play in driving the next wave of innovations? Whoever wants to start can go for it. I see some heads nodding, a little thought going on. So,
what role we should play?
Academia, industry, academia, though. Yeah, let's go for it.
I think that's very philosophical. What is innovation? And I think on one hand, I'm pro developing a big vision and coming up with evolutions of our social fabric. And I think technology is playing a very important role. Being very, very sensitive to the people you are impacting. And that's why we really reach, we have an organization here called Good Systems, and that's trying to bring awareness that engineers, we are capable, and scientists in general, to create very disruptive technologies sometimes. And we cannot do it in isolation and ignoring all the strata and all the communities. So in here we're going actually to many places. We're going to areas, geographic areas where where people just don't believe in technology or believe technology is against them. And then we're trying to understand, first of all, if they might be right? And then understand what areas we have to improve and where to strengthen the vision with the feedback. And second, also try to tell these communities that some of the technologies we develop as a whole, as a country, as a whole world, have really impacted very positively every single person on Earth, right? One of them comes up is the cell phone, right? You go to absolutely any country in the world right now, the most precarious communities, and they use cell phone for banking, for running their businesses. It would be inconceivable to conduct businesses without these technologies. So in a way, I want to see that our vision that we try to create has to be as large as we can. But really, if we can hit that sweet point that we can foresee how this is going to solve the big problems that we have on Earth, like maybe small businesses with people that they don't have the means to start it. It might be, employing and reducing poverty among less literate communities, and whatever it is, that's what we have to address foremost. Yeah, thank you.
This is an excellent point. That we cannot continue playing with the fact that we know the solution. Let me show you that. No, they know what they need, and we need to listen to them. Well, I would like to bring another element, and it is the element that, let me see how I can formulate that. Clearly, by the way we work, we are looking at long-term problems, not the easy problems. Easy problems are not made for academy. So on the way to those, in the way of finding solutions to those long-term problems, eventually someone will make a breakthrough. And this will create the opportunity to disrupt the way the society can benefit from that. And there is a strong tradition on universities, labs, and we have here two people who have created very successful startups that create those startups. Come on, you will be. I'm anticipating.
Okay, thank you. Thanks for the hope.
And then eventually, those startups will be incorporated by larger companies, because small startups are very dynamic, something that big companies are a little bit less dynamic, but they have better visions because they have broader visions and they have way more resources. And this is a way that it is creating innovation, because some of those people will come back to academia, in particular, faculty who take a leave of absence to help establish the startup, and eventually they return. So this is the natural, for me, flow of interactions that has been successful and has to continue feeding the innovation. Now, we are these days, and we heard a lot this morning during Rodney Brooks' lecture, that things seem to be on this moment of breaking because of the access to large, very large, immensely large databases that require enormous amount of computing, and only a few companies can afford to have them, or governments. So there, eventually, we will need to find a new way, if there is a way, for academia also to start collaborating. And academia is finding ways. But this is a disruptive model at these days because of the scales that we are talking about. Unfortunately, not every company can afford to play in that league. So the question is, can academia help spreading these opportunities to smaller companies so that the level of innovation is richer, because there will be many more players. This is something that I don't know still how this can happen, but definitely there is a need, I believe, for academia to enlarge the opportunities, not just for big companies, but for smaller companies.
So I think my role as a faculty to help students being innovative, I guess I want to tie it back to that, helping them to think, helping them to, rather than looking for solution these days in ChatGPT, use their heads. And then more important that, actually I was listening to one of the interviews of the CEO of the NVIDIA. I liked it a lot. He was saying actually rather than escaping from ChatGPT, specifically for the kids younger ages, help them to ask the right question. That's actually, there is a lot of meaning behind this sentence. Even in the research, I tell my students, you are asking the wrong question. By the way, I got it from a nice TV series I was watching. So I watched the whole season. The best sentence was this. There was a detective was saying, keep repeating this. You are not asking the right question. And then the same thing I heard from CEO of NVIDIA. If you, then that's the prompt, right? So ChatGPT, depending on the prompt you're giving to the GPT, it's just giving an answer to you. So coming back to innovation, these days everything is changing. Access to information is easy with ChatGPT. It's like that you know everything. But to be innovative, maybe we need to teach them, okay, rather than actually just going on randomly searching, God help you, somehow you get the answer of your basically question. First say, think, formulate your problem, see what you want to ask to get to the point that you have. Because I remember my day, we didn't have that much of access to internet at best, or like having a Google or whatever, going to library. Right now you have everything. But how to use that is the key. And then using your head to ask the right question is a key to innovation, first. Second one, I as a faculty, I should see. I work with different students. If I see there is a talented student, I should be that funnel to guide it, say, look, this is your personality. Maybe you try this. Maybe your personality is good for commercialization. Go talk to Kyle. Or you are good for this. Because through 5 years we are living with them, I know the personality that they have. That's, I guess, our point, helping them with innovation and translation, or helping them to go this direction or that direction. I think that would be my role, my main role, rather than basically correcting their papers, saying, look here, you need to do that. Helping them with some basically ways, and hopefully they can be innovative and do cool stuff.
Yeah, companies can bring the real world problems, and academia can put the resources to multiple ways to solve those problems and find the optimal one.
Could not have said it any better. Thank you all so much. Okay, so this one is for our faculty. How do you currently partner with industry? Tell us about your spin-off companies.
Okay. We're very organized here. Like 1, 2, 3, 4. Let's follow the rhythm, right? Well, there's many ways we partner, and to be honest, I've noticed an uptick on the number of companies that come to our laboratories. Perhaps it's the situation that we are in right now. National Science Foundation has, is taper off, and maybe it's gonna taper down. NASA also is now in flux, and that pushes us into this new territory where suddenly 60-70% of our grants are actually from industry, and so far, at least from my point of view, has been a delight. I do have great admiration for the problems that industry brings, and I always preach that you can really go deep into any single problem you can think in life, right? You can just look at the floor and do microscopy on the floor, and then start discovering new things, whatever object, whatever problem, whatever concept. So, but the nice thing about companies is that they do and have actually a problem that is already indirectly connected to a commercial path. And therefore, any exploration that you do it has this added value. And I do think that the impact of academia at the end of the day is, how many years is going to be from a product, and how many people ultimately are going to employ the product, right, or the technology. What is the impact? We measure it on publications. Maybe publications citations is a correlate, but more than that is really the millions of people that are going to use, hopefully, your technology. In terms of spin-offs that have come out, thanks to your office, innovation office, and thanks to OTC, and there is a burgeoning of companies coming out. We're still flying below some of the other institutions. Maybe the VC landscape is still nascent. Just a few years ago, we had only, you could count them with a single hand. We have more and more. We have more understanding of who has the money in Texas. Family offices and bringing many small pools of investors together, and that's being consolidated, and it's something, a knowledge that is now mouth to mouth with your organizations. It's happening across faculty, and I would say more importantly, students. Right, our students are really the people that, at least from a point of view, that we want to really. Let them fly, and then give them the confidence at this young age to fly, right? And the IP, and that's what the PhD does, right? There's many successful companies in robotics. We have Diligent Robotics from Andrea Thomas. I think she was earlier on. We have, Aptronic raised $415 million. Recently, I was not aware that it's actually one of the largest in Austin ever, which actually makes me a little bit sad, thinking that it's a small round, but it's still one of the largest, right? So we really need to do more. Now, capital for capital, investment for investment doesn't, for the sake of investment, doesn't make sense. But just for the sake of a shiny new tool. But I do think that with the proper coaching, and with the accelerators that we have here on site, and the companies are helping us, strategic, we really are transforming ideas and things that faculties and students don't think from a practical standpoint. We're turning them into thinking about how this is going to make this sector of our society more productive, right? And I think that mentality has to drive any invention and all these spin-offs. Productivity, to me, is the mentality, and that means the client, that we have to come up with the spin-offs. Thank you.
Well, for me, the experience of when I work with companies is that they have midterm visions. I don't even call it problems. It is more visions, and we partner to see whether there are ways to materialize those visions. Obviously, sometimes you're lucky and you find some answers. I don't say solutions, but at least some answers. Other times you don't, but this is part of the game. The nice thing is that when you find some solutions, the thing that is the most rewarding is that the company then continue internally. And I don't know what they are doing with our initial answers and with the tools that we provide them with to incorporate that into their process. And I know that they are doing that because, to start with, I was part of the patents that they were filling. I don't receive any revenue for those patents because I was not paying attention enough to the way we were formulating the patents, but this is another issue. And no, it is not a fault of UT, because this was in Switzerland when I was faculty there. I have helped some of my PhD students to turn into products the subjects of the research that they were doing for their PhD in the domain of medical devices, exoskeletons like. But again, I was not involved because part of my philosophy is that I want the students to be the owners of their decision-making, learning process. So I don't want to be on their way. So it was a very conscious decision that I helped them to establish the company. I provided them with resources in the initial phases of the creation of the companies, but I never was part of their company so that they could run the company the way they believe they had to run it.
Thank you.
So coming back to the question, how to work with basically industries. Our type of industry is different. If you call it industry, we work with hospitals, surgeons, clinicians. So working with the industry, typical industry, they have a need, they reach out to us and do it. So my type of customers are surgeons or clinicians. If we are lucky, they come to us, and thanks God here, UT is really good. Delmed is close, they come to our office. I was in Hopkins, very hard to find one and then talk to them. Here is easy, they come even. So they are basically the people see the need from different perspectives, from software to AI to hardware, and then we have brainstorming session and try to bring in technology. And if they like it, now with this new generation of clinicians, all of them, they are into, okay, let's just commercialize. I say, okay, it's perfect. Let's just work together, and then hopefully, basically everything is working and we can have a company. But going back to my answer, previous answer is that, so if I know that a student has that talent or interest of doing it, then I can introduce it to some centers like Innovation Center, your office for doing NSF I-Core and so on and so forth, because they need to, on top of research, learn how to commercialize, because that's a totally different skill. So you need to know that writing a paper is very different than having a spin-off company. It's a very different skill set that you need to learn. What is the market? What is basically, and specifically for medicine, is very hard. Knowing the FDA, knowing actually how to get into the hospital, who is buying the device. It's not just a technology, unfortunately, is 10% of it. 90% is the other thing, which is terrible. So somehow convince the people to give you the money. What is the FDA pass phase or any other device, so on and so forth. So all of this takes years of learning, and they need to learn that. And the good thing is that if they learn it early, that helps even in their research. So once they're writing a paper, developing a technology, it's not just inside the paper. They can, after that, commercialize it. So that helps actually knowing the process. We can help them by connecting it to your team, and then having IP early, even teaching them what is IP. There is a difference between a paper, contribution in a paper, being an author, and then an inventor. These are two very different things. And if they learn early, that helps them to commercialize, to have a company, even direct me and saying, let's do this, I want to do that, and that would be very, very effective to me.
I will wrap it up with our last question. Les, I'm going to focus this one on you. What is the hardest part about taking ideas from academia to market?
That is a loaded question, Kyle. There are a few things. Number one, let me say that a lot of times researchers are rocking and rolling, working with their students, making it happen in the lab, and they neglect to disclose some novel idea that has just now been communicated in that publication that went live online last week. Those kind of things, just the process of proactively communicating with our office. We will help you with the process. We have a great team of people in our intellectual property team, our business development team, licensing team. We don't want to put any roadblocks in your way, and we're not going to try to keep you from publishing anything. We want to support that, and we want to get everything we need to do done in the background and keep you posted on what we're finding, how it affects you if it does. So that's number one, communicate with us early and often. The other thing, really with the companies that we deal with, part of my team negotiates contracts for corporate-funded research projects, and another part of my team negotiates licenses when we have IP that's already come out and we want to target a company to license it to, or the startup company to license it to. In those discussions, a lot of times there's some back and forth negotiation of different terms, and companies almost always come to the table with the idea that we're adversaries, because they're companies, and when they do deals in the marketplace with a supplier or whatever, distributors, they're kind of in a certain adversarial role in some ways. Well, the university, what I try to tell these companies, and it will be really helpful, the more people that know this and spread the word, the university is never going to compete with you. We're not going to make anything. We're not going to sell anything. We're here to teach our students, to train undergrads and get our graduate students to their degree points, and to further fundamental research work and to solve real problems. And so, like I said before, when a company can come to us and be really open in talking with us about what their needs are, we're going to go above and beyond and bend over backwards to try to meet their needs in the contracts that we put in place. Because at the end of the day, our goal, we're publishing. That is why we're here. All the commercial stuff is great, but it's not what we're here to do. We're not here to make $1 gajillion on intellectual property. If we do, great, because guess what? A lot of it goes back to the researchers who can take some of it, if they choose to, and fund their own research with it. And so in these times where the government is starting to rethink how they fund research, we need to start rethinking how important it is for us to do technology transfer and to do it right, and to have companies support us doing it right. Because, when companies work with our faculty on research contracts, it's like a triple win. The company gets some really cool research done that they don't have time or resources to do to solve a problem that they've identified. In doing so, they're training PhDs who will graduate and may come to work for them because they're going to be experts in an area that the company cares about, right? And they're solidifying relationships that they have with our outstanding faculty to just keep the process going, spiraling upward. And, there's so many benefits for us, for them. I just need to get that word out because there's too many fights with the companies, and they just don't need to happen. Most of the time that we're talking, I'm just trying to get them to step back a second, right? So that's it.
Okay. Thank you. You all, this has been such a pleasure. Thank you so much for your time. Thank you so much for your insights. Any questions? We're going to do some Q&A.
Q&A if anybody wants to ask any question. Did you have a question up here?
Oh, you want to just hand up right here? Went up pretty quickly. Can I, right here?
We still have 15 minutes. So.
Okay, go for it.
Well, actually, it's not a question. I just want to congratulate you guys because one thing we found at UT Robotics is not only innovative companies, but also moral leaders in those companies. So I see a reflection of those leaders when I hear you speak. So thank you very much for the good work that you've put in.
Thank you.
Thank you. You can pass it there. And then
this is a question. So, I'm a PhD student, and I am working on developing a technical depth, as you've all said. And I'm wondering, how do you reconcile, to start a company, you have to find deep market depth or market understanding. How do you reconcile these two things? I only have so much time. How do you figure that out?
So you're asking, how do you find your time?
No, that would be nice though. What do you need to do to develop market understanding and a technical understanding, and how much do you need to do as a technical founder or a technical person?
I have one story, which is my story, and it has not been certainly smooth, but it has been progressing from day one. My take is that try to make money from the beginning. Try to sell whatever you can. That's one of the lessons. The next one, and that's I'm repeating Peter Thiel, is better to have a monopoly on a small market than be just another fish in a big pond. Potentially, then you can monopolize the market when it grows. That has been a positive experience for me. We sold, out of the PhD student that I had, we sold electronics boards at the beginning. They have some, and actuation, they had some special properties. It was clear to us that we could never sell, or we didn't have the stomach to sell millions of them to make the margins, the profit. But we sold, and then we went on and we sold exoskeletons. And we were always profitable until we started going for seed rounds and Series A's and so on and so forth, right? And at a certain point, it came to us the idea that you needed to really sell. I'm going to say, and I'm here quoting also Steve Jobs, I'm so sorry, that a style of life, right? That really, I think Les was mentioning, companies have, they have this routine, they have to sell money, they have the customers and so on, but I do think it's very exciting when companies are starting to think about selling a style of life. And in particular, the robotics offers this possibility. We are all fantasizing about what it's going to be. I mean, just the amount of imagination that entails our lives when there are robots that put a plate at home, do the basic sanitation. They maintain our facilities in our neighborhoods terrifically. They manufacture, they allow us to be a single person sort of factory, right? Sometimes I say that every human on Earth, in the extreme, it will be an owner of a gigantic company, right? And that will be, you tend to accumulate wealth into a single person, but that single peak, it will be every human on Earth, right? So it allows you to this imagination and play these games. And that's where the opportunity of more money comes in. But you start selling whatever you have and meet, of course, customers, they drive your mentality. You don't have to listen always to the customers, but that's good, right? But also work on their minds. And also playing with the generations. 20 years ago, 30 years ago, you would talk about humanoids, and people would scream about how far off and how scary with this technology. And now we have, with patience, with education, and so on and so forth, suddenly the kids of today, they have grown already with the idea that robotics are going to be everywhere. So as you are young, play. Every time you talk to kiddos, just tell them, and then spread your word, right? And that's going to enhance your probability of success in the future.
Thank you.
Hello. Yeah, so I heard quite a few things about how industry comes to you with their problems and how you help them out, which is more of like a pull situation. So what about research the other way around? Maybe, as a researcher, as a university researcher, you identified some problems in industry, or you have some ideas which you think could be exploited, but industry is not yet at the point where they realize that. So, and so when you try to push it, which is that's more of a push model, that's where you encounter what's called this valley of death, where you've got this idea in academia, and here's industry sitting over here, and you never quite make it through the death valley. So I wondered if any of you have experience with that and how you resolve that.
I will simply say no, I don't have such an experience. Also because the kind of domain in which I work is very nascent. There is not established industrial landscape. When I was talking about those experiences, it is companies that I was not expecting at all, that they were knocking at my door, that they did, and we started the discussion. But yeah, very good point. I don't know whether you have any.
Isn't this a solution in search of a problem, right? And I mean, we don't have a commercialization department, certainly not in our labs, right? So the number of, we meet R&D teams. We rarely meet commercial marketing product teams, right? So maybe that's something we should increase the frequency, and it is happening, right? And what we do have a lot is coming, for some reason, the aerospace industry, Lockheed Martin, Bell Helicopters, a lot of the defense, Boeing contractors, some of the pharma. We were just meeting one of the largest companies just this week, and then what they do is they come over. And they, ExxonMobil and so on, and they come over and they do a tour of the university, and they sample. They spend like 2 gruesome days just checking all the laboratories, and then getting ideas. And then if you ask them, my understanding is that they are really they're really getting fresh ideas that they didn't generate on site. They are pretty satisfied, right? That doesn't mean always that they come back to us and they say, well, we heard this idea from you, we'd like you to lead it. Sometimes it kind of goes in the internal discussions and make their way. And that's a price that we're happy to pay. We want to land some of the contracts, obviously. But I do think that we influence, as influencers of big tech, hard tech, traditional tech, we absolutely do it. But this is organized more at the office of the vice president of research, right? And sometimes you get a phone call. I was in DeepMind, Google DeepMind on Friday in New York City. Sometimes you get a phone call. I was like, oh, I heard you have a committee on safety of physical AI. I want to be part of it. Oh, sure, come over. And here it is, right? You're having dinner in New York City, which is always nice. and then launching a project, right? So it comes in all forms. Like it's a dance, right? It's like you go to a party and you pick a dance partner, and then sometimes it works, sometimes it doesn't work.
So in surgery is different. It happens typically. So clinicians are used to their devices. If you have a new technology, they don't like disruptions. So it's very hard. So then what they say from the very beginning, we want to make sure that what they are used to make devices, which is not have a huge transition. And one way to get around that, let's say I have a technology, I want to go with that, we use celebrities of the fields, key opinion leaders. So if you find that clinician, which everyone knows, and then they start using the device, and they are going to conferences, showing medical conferences, look here, I use this, here is my case, took this much of time, I compared it with the gold standard method, here is the case, then you can get around that. In surgery, that's the only way, and basically surgical domain to go around. Otherwise, if you don't have that guy, you want to adapt to them, phase your basically launching of your product. If you have a robot, you first go with a medical device version of it, make them use it, get used to it. It's cheaper. You don't need to raise a lot of funding, so on and so forth, raise valuation. Then you go with phase 2, which is robotics. So, but if you have, God help you finding that KOL, then it makes the transition much easier.
And would that also apply if you're spinning off your own company too?
Yes. Yeah.
Same idea.
Yes. Yeah.
Did you still have a question?
Luis, I see you smile.
I know, Ardif, for years.
So we've discussed a lot of advanced technology today, and I've heard the panel talk about real-world problems, and I heard the panel talk about, asking the right question. is anybody asking the question, in the conversations you're in, is anybody asking the question of what's the impact on the people at the bottom of the socioeconomic spectrum? The people that are homeless and, you know, refugee camps, everything else. Because under the most benign circumstances of intentions, we can just go so fast that we leave others behind. Are people having those conversations?
Yes.
Is anybody in your circle asking those questions?
Yes. Especially in the domain of neurotechnology, this is one of the most fundamental questions that we are asking. We are far from having massive deployment of neurotechnologies, but the question is, if we do, who will benefit? Who will be paying? Because if it isn't, you cannot expect, especially in the domain of neurotechnology, that the patient and the family of the patient, with all the financial struggles that they have, they will be also paying for that. So does it mean that only wealthy families can benefit from? This is not fair. And associated with that is, who will be owning the data that we are gathering? We need to protect the privacy. So there are many, many of those kind of questions that in my sector we are asking before we have still the technology. Because otherwise, if we ask the question whether the technology is deployed, it is too late.
Any last question? Yes. Last one of the day.
So this is something similar to what Mr. Nichols said earlier. You were talking about a stereotype of how people generally talk in industry when they collaborate with research universities, and how they're maybe too adversarial to the detriment of the quality of the collaboration. And I'm wondering if, in any of your guys' experience, you see a similar stereotype in graduate or PhD students that deters the quality of their research, or how much they're immersed in the essence of their research, maybe habits or behaviors that are to the detriment.
Sorry, you're saying there is a reluctance from the PhD student to innovate because of a perception that the university is gonna take a piece of what they do?
No, I guess it's more general, not necessarily reluctance, just like a habit that people have due to culture or their experiences that, you know, makes these collaborations or the immersion in research of lesser quality. Not anything
Collaborations with companies.
Sorry?
Collaborations with companies.
No, sorry, PhD students in research. That, you know, yeah, collaboration with company maybe, but it's just a general question. You know, how we have this culture that, I guess, stops quality research from being done. And I'm asking it from the perspective of PhD students.
I don't think that any of us has ever seen this situation, but just to be sure that we are addressing your question, I have not seen any difference, neither in the quality nor in the depth of the research that the students have been conducting in my lab, independently of whether they were funded by federal projects or projects that were funded by industry? Nope. Absolutely not. I have never seen in the examples that I was simply mentioning, no details, of those students that clearly towards the end of their PhD wanted to continue that kind of research because they wanted to bring it to the market. And it is not that they were all of a sudden not sharing some knowledge because they wanted to use that knowledge for their company rather than communicating that to the lab. So I have never seen that. Maybe these two examples help answering your question.
Okay.
That can be a little bit unfortunate if that happens. I think there's openness and there's a lot of general sincerity between faculty and students. There are politics obviously in academia as everywhere, but it is one of the purest areas, domains that I know of, and perhaps is less driven by economic incentives, and also faculty are in an ivory tower, which we work very hard, but then the students are not going to take your job, right? And therefore, our job is to make these guys the best possible. There is no sort of a relationship of competition in general, and that produces a very healthy relationship. Right, Kyle? Yes.
You will graduate. Don't worry about it.
Awesome. Well, thank you all so much. I really appreciate the panelists and the moderator today. Great first day.